I'm Eli Turner, Senior Geologist, and I'll be talking about origin royalties as well as our hot tip epithermal property in eastern Nevada, which is available for option or sale. I'll be making some forward-looking statements during this presentation. Origin is a royalty company that formed through the merger of two prospect generators, so organic royalty generation is a major focus for the company. Essentially, that means staying true to our prospect generator roots and doing early stage exploration to identify prospects of interest, getting them into the hands of a partner company to advance them, and retaining a small royalty interest, among other deal terms. We also engage in royalty acquisitions, but on a more selective basis. It has to be a very compelling opportunity at the right valuation for us to get involved in that way. But an example of a recent acquisition would be the Larica porphyry copper royalty that the company acquired in Colombia in 2023. It's worth noting that our two flagship assets, the producing Ermitaño royalty and the development stage Silicon royalty, both came from this organic royalty generation pipeline. Through royalty creation and acquisitions, Origin's built up a global portfolio of 30 royalty interests, as well as additional mineral properties that are optioned out to partner companies. To a significant degree, our portfolio is anchored in North America, where we have 19 royalties, including both of our flagship assets. Our Nevada operations constitute a big part of what we do in North America, where I mentioned our portfolio is more or less anchored. We have an exploration team here in the state and 11 royalty interests, which is just over a third of all of our royalties globally, with 6 active option agreements on properties in the state. On top of that, we have 3 mineral properties that are available for option or sale, including hot tip, which I'll get into shortly, and we have more that are up and coming in the project pipeline. A really productive engine for us in Nevada has been an exploration alliance with Altius Minerals that has been going strong since 2022 and is slated to continue next year into 2025. The main focus of that alliance has been exploring for silicon analogs, since that project was initially born from a similar exploration alliance between precursor companies to what are now Altius and Origin. In the context of the classic Buchanan model, which is the figure shown on the slide, essentially as a cross-section through an idealized epithermal system, the search for silicon analogs begins with identifying features consistent with the upper levels of a fully preserved epithermal system or one that's experienced a minimal degree of exhumation since being formed. Those features can be steam caps, water table silica, silica centers, and there are many groups in Western North America that are approaching the exploration for epithermal gold systems in this fashion, having at least some degree of success. Everyone has their own unique approach, but at Origin, our particular approach is leveraging our in-house remote sensing expertise, which is provided by Mark Coolbaugh, our chief geoscientist in the Reno office, to identify anomalies that could represent large argillic alteration cells that are poorly tested steam caps, then going out in the field to make some additional observations and use a variety of methods to make an interpretation on the environment of formation of the argillic alteration cell in question. And ultimately, we frequently stake the ones that we believe are consistent with poorly tested gold-bearing steam caps that could overlie blind epithermal gold mineralization at depth. Hot tip is an example of one of these projects that we think could be a poorly tested steam cap over a gold cell. Origin picked up hot tip in 2023, and it comprises 109 claims in Nye County, Nevada, just a few miles off Highway 6 between the town of Tonopah and the town of Lund. Hot tip is located within a larger alteration trend that includes the historical Silverton district, just a few kilometers to the north. Hot tip and Silverton are both on the edge of an Eocene to Miocene caldera field. Hot tip initially captured our interest because it's a sizable advanced argillic alteration cell on the order of 3 or 4 kilometers in diameter with highly anomalous Pathfinder geochemistry. One of the first things that we did after becoming interested in hot tip was process the available AVERS hyperspectral data that covers the area, which we don't believe had been done before by previous groups during exploration in the area, although it's publicly available. And in doing this, we were able to see that the clay mineralogy at hot tip is dominated by kaolinite, which is shown in orange on the figure to the right, but that there is a central core of coherent alunite, shown by red in the figure. Alunite, of course, is a mineral that is stable in more acidic conditions than kaolinite, and in many cases, in advanced argillic alteration cells, it can be found more proximal to controlling structures, coarsely reflecting fluid flow pathways during alteration. In this case, the alunitic core is situated within a graben, so there's a clear structural control, and we think that this is a good candidate for an upwelling zone within the epithermal system. Nearby historical drilling returned up to 0.4 grams per ton gold over 24 meters, so there's clearly anomalous gold floating around in the system outside of what we think is its center. The photo on the bottom left was taken from the south of the property, looking north into the core of that altered graben, which is our main target. Looking at the regional geology, the property is on the east edge of the Pancake Range in Nevada, where it meets Railroad Valley. It's on the perimeter of the 36 to 18 MA Central Nevada Caldera Complex, which was produced through a series of ignimbrite eruptions related to slab rollback magmatism. Hot tip is very close to the intersection of the 32 MA Williams Ridge caldera to the south with the 28 MA Monotony Valley caldera to the north, although the age of the hydrothermal system itself at hot tip is not well constrained. Origin has been particularly interested in the caldera fields of central and eastern Nevada lately because, in our opinion, the geology is very prospective and there are robust epithermal systems to be found, but they remain very underexplored relative to the Walker Lane and calderas of western Nevada. In terms of the property scale geology, the alteration is hosted by Oligocene rhyolite tuffs and dolostones of the underlying Nevada Formation. Here we're looking at the Nevada Formation in purple and the overlying tuffs in orange and light blue. Although the unconformity with Paleozoic rocks is obviously shallow, the thickness of volcanic cover on the property does increase a bit within the central graben, getting up to about 500 feet thick or so, according to previous drilling. As I've already alluded to, the clay alteration at hot tip consists of a central zone of alunite, shown in red on this figure, surrounded by a larger halo of kaolinite, which is shown in orange. But in detail, there are smaller amounts of alunite and dicite that are disseminated throughout the broader kaolinite halo. Processing the publicly available AVERS data, as I mentioned, as well as going out into the field and collecting hand samples, were both very important to getting the distribution of alteration minerals pinned down. I should note that the core of the alteration cell, which is that alunite bearing zone within the graben, also contains abundant kaolinite and pyrite. So one might be forgiven for thinking that the alteration at hot tip could be supergene in nature. But this is clearly not the case in our opinion, because if you look around in the alunite core, it's relatively easy to find rocks that are completely unoxidized and have 30+% disseminated pyrite. And even in those cases, if you shoot the rock with a tabletop spectrometer, then you get a very strong alunite signal from the matrix. So clearly the advanced argillic alteration, the low pH alteration is not related to supergene oxidation. Notwithstanding that, we do believe the alteration at hot tip is low temperature in origin, as indicated by variations in the composition of alunite across the property. There's also widespread and often pervasive silicification at hot tip, both within the Devonian Nevada Formation, often forming jasperoids, as well as in the overlying Oligocene tuffs. The alteration at the property is open to a significant degree undercover to the south. You can see that there is a circle of orange pixels in the figure that's separated from the main alteration cell at the very southern end of the claim block, and Those orange pixels indicate the location of an outcrop poking out from an area of post-mineral alluvial cover, and that outcrop is strongly altered. It's silicified and bleached and has locally visible cinnabar, and clearly indicates that the alteration cell extends a couple kilometers to the south beneath post-mineral alluvium. The alteration is likewise open to the north and east to some degree, although that's not as well constrained. Here's another photo looking to the south, standing within the graben at hot tip. In the foreground, we're looking at that alunite pyrite kaolinite alteration, which is the strongest alteration on the property right in our main target zone. And then off towards the horizon, you're looking at the covered southern extension of the system that I was just talking about. In terms of geochemistry, the alteration at hot tip is very metal rich, particularly in Pathfinder elements associated with gold systems. In the figure on the right, we're looking at arsenic in rock chips. Arsenic values as well as antimony values in rock chips locally get up to over 1% in select rock chip samples. Mercury gets up to 245 ppm. There are occurrences of cinnabar and stibnite, visible cinnabar and stibnite to be found across the property. And gold can locally be anomalous as well, exceeding 100 ppb in rock chips, but there is some more serious gold anomalism to be observed in historical drilling. Speaking of which, historical work at hot tip really began in the 1980s when Fisher Watt drilled 18 holes on the property with an average depth of 71 meters. Most of that drilling was focused to the northwest of our main target area, and the collars for that drilling are shown in gray dots on the figure. The best intercept was 24 meters of 0.4 grams per ton, as I mentioned earlier, and this is a bit distal to what we're thinking of as being the probable upwelling zone and structural guts of the system at hot tip. In 2017, core mining drilled 9 holes that likewise didn't test meaningfully the structural zone that we're interested in. The core holes are shown in black dots on the figure to the right. At hot tip, we also have sourced historical gravity and gradient array IP data sets. And the IP in particular has been very helpful for refining the target concept and getting an idea of what's going on beneath alluvial cover in some places of the property. It shows us that the area of alunite pyrite alteration, which on the figure is noted by the dark pixels, corresponds to a chargeability anomaly of greater than 15 millivolts per volt, which is indicated by warm colors, sort of orange, yellow, and white on the figure to the right. And of course, that chargeability anomaly is explained by the disseminated pyrite that occurs with the alunite alteration, which can sort of be in the tens of percent. But because the chargeability high extends well beyond the existing outcrop of that alteration, we can infer that the alunite pyrite zone, and thus the acidic core of the system, is a fair bit bigger than it appears and measures something like 1 by 2 kilometers, maybe a little bigger. And of course, this is a gradient array IP data set, so there's limited depth information that can be extracted, but there are some very high chargeability zones within that greater than 15 millivolt per volt anomaly. Those are shown in white, and they could be consistent with deeper sulfidic structures that are feeding this acidic alteration in what we think of as the base of a potential steam cap. A couple of other things to note. Resistivity highs in the gradient array data are usually indicating dolostone of the Nevada Formation, which is all of the highs that you see off on the right side of the figure. But they also track to a significant degree silicified tuffs on the property, which explain the highs on the left side of the figure. There's a resistivity low in the graben, which probably reflects a greater preserved thickness of volcanics and more strong argillic alteration. We're not looking at the gravity in this figure, but as you would expect, there is also a gravity low within that graben, reflecting the increased thickness of volcanics. We envision the potential at hot tip as high-grade epithermal veins hosted within basement rocks of the Devonian Nevada Formation. If we distill this down to the fundamental tenets of a magmatic hydrothermal ore deposit, where you need heat, fluids, metals, and a precipitation mechanism, you obviously have heat, fluids, and metals, as evidenced by the large, low-temperature, advanced argillic alteration cell with anomalous arsenic, antimony, and mercury. So what remains in question is whether you have a precipitation mechanism that deposited a sufficient amount of gold. And in postulating that this is a steam cap, we're putting forth that boiling could be that critical process responsible for gold precipitation at depth, as well as the hydrolytic alteration you see at surface by way of sulfuric acid that's condensing out of steam rising up off of the deep boiling zones. The alteration clearly vectors towards the central graben at hot tip, with the lowest pH stable minerals being there, so that's an important structural control and likely upwelling zone within the system in our view. What we're illustrating on this cross-section is high-grade gold veins as the deep structural roots to the alunite, kaolinite, pyrite alteration observed at surface, which we suggest is the base of a steam cap. We think of our play at hot tip as being analogous in some ways to the Hishikari deposit in southern Japan. This is an 8+ million ounce system where high-grade epithermal veins are hosted dominantly within pre-mineral basement. In this case, the basement is mostly Cretaceous sandstone, and the overlying volcanics and hydrothermal system are Quaternary. Importantly, Hishikari is in a district known for volcanic-hosted epithermal occurrences, so finding the largest deposit in close association with the Mesozoic unconformity was a bit of a one-off surprise. Most of the mineralization at Hishikari is beneath a couple hundred meters of volcanic cover, which is similar to the preserved thickness at hot tip in our central graben. The veins at Hishikari are sulfide rich and have a distinct chargeability anomaly, and although we haven't done any dipole IP at hot tip to really speak to that, the gradient array chargeability anomaly that we have is consistent with that possibility. I should note that at Hishikari there is an argillic blanket above the veins, but it's smectite dominant and doesn't really constitute an advanced argillic steam cap, although maybe that's not surprising in the relatively wet volcanic arc climate of modern Japan. IP and gravity were apparently the most important geophysical tools for making the Hishikari discovery, since they help delineate basement highs and distinguish resistive basement from low resistivity volcanics, which are all relationships that we've seen at hot tip as well. It's worth mentioning how hot tip relates to the Silverton district, which is a well-known historical silver district a few kilometers to the north. They're both on the eastern margin of the Williams Ridge caldera and have extensive argillic alteration, although there's apparently less silver mineralization at hot tip than at Silverton. Silverton is quite structurally complex, with the mineralization actually being hosted within the Williams Ridge caldera, and much of the mineralization is hosted by rootless blocks of Paleozoic basement within the intracaldera tuffs, which are a bit cryptic and might represent slide blocks or foundered blocks of the caldera walls, or alternatively highly tilted slices associated with basin and range extensional faults. But at hot tip, in contrast, the structural picture is less complex. You have clear central high-angle structures towards which alteration vectors without evidence of significant horizontal displacements, and these central structures have not been well tested. To sum up the play at hot tip, we believe the project could represent the poorly tested steam cap of a metalliferous gold system because it is low temperature, gold poor, and clearly not supergene. New mineral mapping, mostly using hyperspectral data, helped vector towards controlling structures for, we believe, the first time on the property. Geophysics has farther enhanced that, and an important takeaway here is that if boiling occurred at hot tip, it would need to be very vigorous and extensive to produce the observed alteration, giving you a chance at a truly sizable gold deposit. Again, hot tip is available for option or sale, and we encourage everyone to reach out with any questions.